Okay, so this is a circle theorems question, but it's got a bit of a difference because we don't actually have any values, so everything's in terms of x, which makes it a little bit more challenging. So before I start, I'm just going to label these two as radiuses, just so that I remember later. I also know that I've got a 90-degree angle here and here, because that's where the radius meets the tangent. And thinking ahead, I can see that I've also got an arrow theorem here. So I might need that later. I've also got a quadrilateral here. I might need that later. I've got some right angled triangles. So I'm just having a little look to see what I've got so that I can think about using those later. So the first one is to write down the size of angle OBP. So O to B to P is this angle here, which I've just said is 90 degrees. It's where a radius meets a tangent. And then the next one is angle AOD. So A to O to D. So it's this angle here. So I could use this one as an isosceles triangle. So let's look at this one here. So it's an isosceles triangle, so if this side is x, therefore this must also be x. In which case, this one at the top here is just 180 for this total in a triangle, minus 2x. But I want half of that because I'm interested in only this side. So half of that, if I divide it all by 2, is going to be 90 minus x. Okay, so I'm just going to label these on in case they're useful next. So that's 90 minus x, and this one is 180 minus 2x. And now it wants me to find ACB. So A to C to B is this angle here. And this is actually the arrow theorem that I looked at earlier. So this angle here, which is the 180 minus 2x, if I halve it, it's this angle at the side here. So it's going to be half of 180 minus 2x, which is actually exactly what I've just done. So this is 90 minus x as well. And then the last one is angle APB. So A to P to B is this one here. And I have a quadrilateral, a four-sided shape. I know that I've got 90, 90, and I've just said that this is 180 minus 2x the whole way across. So I can now find this one here. So it's 360, which is the total in a quadrilateral, minus my 90 and my 90, minus my 180 minus 2x. And I should put brackets there to help me. So 360 minus 90 is 180, minus 180 minus 2x. So if I multiply out that bracket, 180 minus 180 plus 2x simplifies to 2x. And then the last one is the mathematical name of the quadrilateral AOBP. So this is the one I've just been using, and this is what we call a kite. A kite has two lengths that are the same, two other lengths that are the same, and it's symmetrical. So we can see there that it's a kite in terms of the mathematical shape.